Okay, I did not. I skipped these two pages because I thought they were stupid. I did up to here. And I only have
of these types of problems here. So this one says
like
cutting
4
the top of the top of the house from the front yard. So essentially, we have some sort of tower that has a clock on the top, and you guys know how. The clocks that are horizontal distance from so you've got food over here somewhere at her house, and you know that the 40 meters. If the angle of elevation from where she stands in her yard to the clock is 3 degrees, and that angle of elevation there, so you get the angle of elevation down to 15 degrees. What is the elevation of the clock is your eyeball above the ground? So that 1.6 will be after we solve it here. Essentially, what we're going to solve for is we're so this is a tangent problem. It is a tangent of equal to opposite is x over adjacent is 130. And so you set that up, you solve that that would give you about 37.5. And that gave me 39.1. Just being able to read a problem and then solve research from there. So being able to do that. I'm actually going to cross off the second one. We're going to save ourselves a little bit. Okay, 9.7, we talked about the law of sines. So just and then write whatever you want, but the law of sines. You can do this in either order, but it says that the sine of angle A and then is equal to B over the sine of angle B. So see in there, if you wanted to, you can flip the sines over, you can do it sine of A over A. Any of those things are fine, but you can set up a proportion. So in the law of sines, if you're going to use this, you have to have an angle side opposite pair. So in this one, given the 80 to the 47, you can solve for angle Y. That is 51. Again, you're going to use your calculator on the final, so use your calculator, find it real quick, don't write those out, just figure yourself out. So I do have a sine angle opposite pair right here. Okay, so that's I'm going to use that. And in this case, I'm solving for x. So the other side angle opposite pair, I'm going to use it over. Okay, I'm going to ignore the z and I'm going to ignore the 47. Not using those. So if I want to set this up, I can do x over the sine of 82 equal to, and then that would be 16 over the sine of 51. Right? It is not the same thing as x over 82 equals 16 over 51. You have to do the sine of that. Long sine here. Okay. You want to do it in different order, that's fine. If you would cross multiply in this case. So what you can, if you figure out that this is what you're doing sine of 82 times 16, and then you have to divide by the sine of 51. That gives you x. So if I don't want to completely cross multiply to get this x here, I can just multiply by the sine of 2. Your answer in your calculator should come out to 20.4. Again, remember, I'm taking everything in the nearest 10th unless it says otherwise in this review. It'll tell you what to round to, which is mostly the nearest 10. Okay. If you get to this type of a thing, if you go home and you try this out and you're not trying to do it, come ask me. Okay, let me know and then we can go through that. The other one here is kind of the same idea. I have an angle side opposite pair. Remembering that your big R and your little r are opposite from each other, right? Same thing with everything else. It says solve the triangle, which means that you want to find all of the sides and all of the angles. I'm going to assume that there is a little t. There's a measure of angle t that I need to find, and then there's a measure of angle s that I need to find. So those are all the things that I'm going to to solve for in this one. Okay, so the first thing I'm going to solve for is the measure of angle S because I'm given the little s. So I need something where I know part of it. Okay, so using that to measure angle S, I'm going to do the sine of S over little s, which is the 8, equal to the sine of the angle that I know, which is the 136, over the one that's opposite it, which is the 13. Okay, so I can solve this. Again, I like to put my variable on the top left, so that's why I switched up my sine ratio in this case and did it with this one. Okay, then I can multiply by the 8, so I end up with sine of S equal to, again, whatever you would get out of this, I put in my calculator, right? Sine of 136 over 13 times 8 is what I did there. And then to get rid of the sign, again, I did all this in my calculator. I had a decimal in my calculator, and I was like, okay, to get rid of sign, I take an inverse sign. So I took an inverse sign of whatever I had from all of that. And then that gives you S. So your angle S in this case comes out to 25.3. If you are solving the triangle, so notice I put myself 3 blanks, because if you're solving a triangle, you need to give me all of the measures. So this is everything that's left. If you have 2 angles, you solve for the third angle by just subtracting from 180. You do 180 minus 136 minus 25.3. My measure of angle T would be 18.7 in that case. The little t then, you have to solve a law of sines again. Okay? You would set up a second law of sines. Second law of sines, I would do little t over the sine of t, so that's the sine of 18.7, equal to, and then I'm going to go back to my r's. So I'm going to do 13 over the sine of 136. Technically, you could use your s because you solved for the other piece of it. I don't like to use something I solved for in case I made a mistake, so I'm going to use the least amount that I can there by doing that. You take 13 divided by sine of 136 times the sine of 18.7. I did use the decimal that was in my calculator for that 18.7, which may make a difference depending on what you do. But I got t to come out to approximately 6. And that was my last piece. So when you want to take away from those two problems as law of sines, I just did law of sines 3 different times, and you can kind of see it in different ways. I'm not worried about the solve the triangle. Every one of your answers is going to be one thing, so you're not going to have to worry about solving the triangle. But you do need to know how to use law of sines. Then 9.8 is the law of cosine, which is a lot longer. The law of cosines, and the letters in this one, just be careful with whatever you want to use. I am going to use A's, B's, and C's, and none of these, so that'll help a little bit. But I can say C squared is equal to A squared plus B squared minus 2 times A times B times the cosine of big C is what it would be here. So C squared equals A squared plus B squared. It looks like minus 2 times A times B times the cosine of the angle C. So that's your law of cosines formula. How does it come about? Well, we got to look at what we have. So here's my x that I want to solve for right here. Your variable will either be in the C, in one of those 2 C positions is where it's going to be. Okay, and it's because I've got my x that I need to solve for in the 77. Those 2 pieces that I know have to be opposite each other, have to be in those spots. So for this one, I could set up x squared equal to 14 squared plus 20 squared. There's my a squared plus b squared. Minus 2 times a times b, so 2 times 14 times 20 times, the order of the 14 and 20 does not matter, okay, times the cosine of c, which in this case is 77. Now, since the entire right side of that problem is, because there's no variable, you just type in that entire thing, you get a decimal, and then you realize that to solve for x squared, you take a square root of whatever you got there, and it gives you your answer. Okay, so it's the hardest part is setting up the long cosine. But again, you get your notes, so you have it written down right there. Make sure you know where it's at, and then you get your answer. Your answer from this one would come out to 21.7. Again, if you start to type some of that in and you have questions, just let me know about it, and we can go from there. So if I look at this other one, the variable is the angle. Okay, so again, the angle side opposite pair that you're given is what's going to be your C's according to this diagram, right? So my C, my little c in this case has to be the 16. So I would set up 16 squared equal to, and then it's going to be 13 squared plus 25 squared minus 2 times 13 times 25 times the cosine of c, which in this case is an x. So I'm going to fill in the x's there. You can leave a c, it doesn't really matter. As long as you're solving for a variable, you're good. Okay, when we solved the piece, we did it in kind of 3 parts at the beginning. You solved 16 squared, you solved 13 squared plus 25 squared, and then you solve 2 times 13 times 25. So that's the first thing that you want to do is solve each one of those separately. I'm going to write these pieces out. So this is 256 equal to, and then we had 794 minus 650 cosine of x. Okay, so that's the first thing that you do. Then you have to get down to where you cosine of x by itself. So you subtract 794. Okay, subtract 794, which gives you, I don't have that one right now. Subtract 794, and then you divide by -650. So you have to do those in that order. So make sure you do the subtraction, hit enter, and then divide by that. That's going to give you 269 out of 325 equal to the cosine of x. And then you take an inverse cosine of what you have there to solve for x. In this one, you should get 34.1. Again, with 9, 7, and 9, 8, you may want to go back and type those in and make sure you know how to do it. And you get the same answer, and if you don't, then ask questions. But that's how you do it. Okay, any questions there? Yeah. You're just solving for cosine of x. So how do you do that? You got to add and subtract first. You subtract the 794. And then how do you get the, and then you have -650 cosine of x. You have to divide by the -650. You gotta solve through that. Okay, we're gonna move on to chapter 10 and 11. And again, I'm not gonna rush it. If we don't get to something, we'll go through it. Ask somebody here. Okay, this is me and the other class. I don't know why this is. There it goes. Okay. Okay. So we have naming the circle, naming different parts of the circle, and going from there. So naming this circle, this is circle T. You do a circle with a dot in the middle and a capital letter. That would be circle T. Chords of this circle. So chords go from side to side of the circle. You do have LM that is a chord. Yes, it is a diameter, but it is also a chord. And you have JK that is a chord. So if you're naming all of the chords, you would name both of those. Okay, TM is not a chord. The diameter of the circle we just said is LM. So you have that segment there. Put your segment bar above it. It's asking you to name it. You're naming it. You're not giving you the measurement of it. Okay. And a radius not drawn as part of the diameter. So this one right here is the one not drawn as that. So TN would work. If you mix up those letters in the different order or whatever, that's totally fine. Okay, you can do that. But you have those same letters that are there. In this other one over here, they give you C equals. You need to know that that means that's a circumference. And my circumference formula is pi times b or 2 pi r. Okay, either one of those would work. You do need to find diameter and radius in this one. So if you, it doesn't really matter which way you solve for it first, but if I do pi times d, then 32 is equal to pi d. That's my circumference equal to pi d. Divide by pi, and you're actually going to divide it in that case then. And if you divide that out, you get 10.2 for your diameter. And then if you have the diameter, you divide that by 2 to get your radius, and your radius would come out to 5.1. So make sure you understand if you see a C equals, that's what you're given, especially if it talks about diameter and radius. In 10.2, Major arc, minor arc, or semicircles. Remember, the major arc are the bigger than 180, the minor arc are smaller than 180, and the semicircle is equal to 180. Okay, so an arc JL, if I find J and I go to L along the arc there, is equal to the measurement central angle. You do 44 plus 48 in that case, that gives you 92. Okay, and it is a minor arc because it is less than 180. Okay, so you get a minor arc out of that. LKM, so if I'm going from L to K to M all the way over here, okay, we're going to add all the central angles together. Now, some of you are like, well, NM, there we don't have that one. You do. You have a vertical angle. If you look at these lines, you have a vertical angle, so that is 48 degrees. You can add all of those together, where I did 180 plus 48, however you want to do it, you get 228. And that makes that a major arc. Again, minor and major just simply based on is it bigger or less than 180. So know your minor and major arcs here. Changing degrees to radians and radians to degrees. So 270 degrees to radian. So I have 270 degrees. It's pi and 180 is how we change. So 180 degrees is equal to pi radians. So if I'm changing 2 radians, the radians go on the top and the degrees go on the bottom. So the reason I can multiply by pi over 180 is because that's equal to 1. Pi radians and 180 degrees are the same thing, so that fraction is equal to 1. Okay, and that's going to change the problem for you. On the final, you have to give it in terms of pi, which means you're not multiplying by the pi. So all I typed in my calculator on this one was 270 divided by 180. It gave me a simplified fraction that was 3 over 2, and we have to put the pi in with that. So we write it as 3 pi over 2. That's the radians. Okay, so if you are converting degrees to radians, you're multiplying by pi over 180. Do the exact reverse here. If I have 2 pi over 3 and I'm converting to degrees, then I multiply by the 180 goes on top, the pi goes on the bottom. Okay, those pi's, since you have 1 on top and 1 on the bottom, do cancel out. That's how multiplication works. And then you do 2 times 180 divided by 3, it gives you 120 degrees in this case. Right? Again, you can type it in your calculator even before you cross out the pi. So you type that in your calculator if you wanted to. But I like to simplify and save myself some of the calculation. Okay, so converting to radians, converting to degrees. Again, you get to use your notes. So hopefully you use them to your advantage and you know what you're doing there, and you can do that pretty quick. Okay. Find the length of an arc. If you know the length of an arc, it is part of the circumference. Okay, so your part of the circumference here, the circumference. That means that I need to find what part it is. So it wants to find the length of arc CB. And so if I find CB out here, it has an angle measure of 99 degrees. So to find the part of the circle that this is, I do 99 out of 360. Okay, that's the part. Of means multiply. And then the circumference, it gives me my diameter. So the circumference here is 23 pi. Pi d is circumference. So 23 pi would be my circumference there. You just type all of that in your calculator and give this as a decimal, and you would get 19.9. Okay, 10.3, we got into chords of circles and how we could solve with them and different angles and things like that. So in this one, we want to find X over here. The only reason that they give you the 23s here is because if these chords are congruent, that means that these 2 arcs are congruent, which means they have the same measure. So all the way around the circle is 360 degrees. So here you would do 360 minus 96. That's going to give you 264. That's left over from JKL, and you divide that by 2 because that gives you one of those, which is how long X is based on what's given there. So you get 132 for your X. This next one is probably, again, one of those little tricky ones. I'm going to put a little star next to it if you want to. You can, you don't have to. The big idea with circles is you have a radii help you. So if I start to fill this in, DB it gives to me as 5. I'm not actually going to fill that in yet, but I am going to recognize that that is a radius. And so that's going to help me a little bit. CA is 8. So I know that is 8 based on what is given in this figure. I do know that each of radius that is perpendicular to the chord. So that's DB perpendicular to CA there. You do know that it bisects the chord, right? So we have that. And we want to find AE. Well, there's my answer. Right? You don't have to make it more complicated than that. But that's what I know. If you were asked to solve for DE, for instance, make sure you remember that there is a radius that I can draw in right there, and I can fill it in this 5. Okay, I'm just giving you extra little hints there, but that's what you could potentially do. The last one over here, it says in circle Q, RT is congruent to VT. So what that means is that these arcs out here are also congruent. But essentially, we have congruent chords, and what we know about congruent chords is that they are the same distance from the center. So the reason that QS and QU are drawn in here and they're drawn perpendicular is because they represent the distance to the center of the circle from those chords. So based on RT and TB being congruent, then those segments are congruent, so those chords are congruent, and therefore the same distance. So they tell you what SQ is and they tell you what UQ is, and you just set them equal to each other. So 3x minus 2 is equal to 2x minus 1. You solve that, you get x equals to 1. Okay, so again, what you're using there is that congruent chords are the same distance from the center. Okay, the circles continue. And we started talking about angles. We talked about inscribed angles. Giving you some words and feeding back this stuff. So we talked about inscribed angles here. If you're trying to find angle F, you know that it is half the measure of the arc that matches up here. So in this one, they give you these two arcs. So you can take 360 minus 150 minus 144. I did all of that in my calculator, just write it there so you can see it. I got 66. So that is that arc there. Right? And then you just take that and divide by 2, and that gives you that angle, which is 36 degrees. So the inscribed angle is half its intersection arc. In the second example, if you have multiple inscribed angles, there's a few things that you're going to look for. One of them is, do they open up to the same intersection arc? And so this is what this one does. This angle K and this angle J both open up to arc LM. No, I do not know how long arc LM is, but I know that an inscribed angle off of it is half of its measure, which means that if both of them are the same, they're both equal. So in this one, I can set 3x plus 5 equal to 4x minus 6. And so x is going to come out to be 11. And then you do the same thing with the other angles, angle L and angle M, both open up to arc JK, which means they have to be equal to each other. So you set 7y minus 1 equal to 6y plus 3, and you come out with a y value of 4. Okay, so those inscribed angles, if they open up to the same arc, are equal to each other. Then the last one that we have here is that if you have an inscribed quadrilateral, then you know that the opposite angles are supplementary. They're not equal to each other. You know that they add up to 180. We did it with the arc measured all the way around since the circle was 360, but those opposite angles are supplementary. Okay, so you can do this one in a few ways. You could actually solve this without knowing that because you know that the angles all add up to 360 and you only have one variable. Okay, but if you want to make it a little bit simpler, you can just pick one of them. So let's say I pick the 5x plus 1 and the 79. I can say that 5x plus 80, so I put 79 plus 1, is equal to 180 because they're supplementary. And then I can solve from there. And you're going to get that x comes out to be 20. Okay, so opposite angles are supplementary. Now, make sure you understand, I didn't do an if there, okay? If you have an inscribed quadrilateral, and opposite angles or something. Okay, that's what we have in that picture. 10.5 started talking about tangents to the circle and what we know about those. So this one says just is ln tangent. So sometimes we say assume it's tangent, sometimes we say is it tangent. Usually unless it asks is it tangent, you assume that it's tangent. Okay. And you go from there. But what we know about a tangent to a circle is that it forms a 90-degree angle with the radius. So just like it looks like there, that's what you're doing. And then you essentially just solve the Pythagorean theorem here. And all we want to know is it equal or isn't it? So I don't care less than, greater squared plus 36 squared, and I want to check if it's equal to 39 squared. That's all I care about in this one. And you will get 1521 on both sides, and therefore you say that yes, it is tangent. So if it is a right angle, then the answer is yes, that it is tangent. Your second one here, you have two tangents, so these are tangents. So you have a tangent and a tangent. We're not worried about that 90 degree. And if you have two tangents that connect to the same point outside, they are equal to each other. So that's all you do here. 2x plus 10 is equal to 3x plus 6. So your x value is going to come out to be 4. Last one there, if you have a figure that is inscribed, a circle that is inscribed in a polygon, or a polygon that is circumscribed on a circle, which is what both of those are, then your tangents, you have a bunch of these sets of tangents that are congruent to each other. Okay, so this piece up here, so tangent from that piece to that piece is labeled as 7. So the other piece from the same point outside, this piece over here is 7. Okay, so those ones are the same up there. Then you can move on, and you have a 7 down here. So that piece right there is tangent to the other piece that comes off of the side. So those ones match up. And then lastly, your 9. So you got that tangent there and this tangent here that are the same. And so you would have those pieces that match up. Okay? So knowing that those, it's not the ones that are on the same side of the triangle. It's the ones that touch the same end point of the triangle. Okay? If you add all of those together, you would get 46. Now, if you're wondering at all, like, okay, when we get to the final, is it going to be more complicated than this? No, like, this is what it's going to be. I actually went through the final, and like some of them I marked it as I was trying to figure out where it was at. And like I marked it easy was like you don't have to do any work, you just have to like answer a question or whatever. Versus, oh yeah, thank you. Oh, that's not even ours either. Okay. I did that. Okay. Gotcha. Yeah, I did. Okay. But it's things like this, like that's what you're running to. So this middle one that's right here, I mean, that's exactly what it's going to be like. Okay, so you can go through and see those. We have the easy ones, and then I went through like the medium, like it's got like a step to it, and if they were like that, that's the majority of the final. Okay, so what you're seeing here is what I need you to know for the final, and if you know that, then you should be pretty good for it. Okay, 10-6, we start to talk about all the other angles of a circle. So this is not necessarily a central angle. So you have to be careful with that. We don't have that little dot in there or anything like that. We don't assume it's a central angle. But if you had an angle inside, so this is one where there's an angle inside the circle. Okay. Then what we did in this case is we take 21 plus 29 divided by 2. You take the two arcs that are essentially vertical angle arcs kind of thing, add it up, divide by 2. Now that measure comes out to 25, which is that angle that matches up with both of those arcs. Okay, both of those angles are 25. So to find the measure of angle 1, you just simply in this one had to do 180 minus 25, and you get 155. Okay, but if the angle is inside the circle, you add up the two measures and divide by 2. Okay, this next one is the angle is on the circle. Right, it's the same as an inscribed angle. It's not an inscribed angle, but it's the same as an inscribed angle, where the angle is half its intercepted arc. Okay, so if this angle is given to us as 68, then this arc is double that. We're going to multiply by 2 to get to that arc that's right here, which is 136. And the arc that they want here is TWU, which is the opposite of that here. Okay, a circle 360. So if you do 360 minus that 136, and you get your answer here to be 224. So angle that is on the circle is half of the arc that's intersecting. That's what that one's going over. And then the last one over here has an angle that is outside the circle. And for this one, you're going to take, you're going to take the two arcs and you're going to subtract. You're going to take your biggest one, which is 52, minus your smaller one, which is 18. Minus 18, and you're going to divide by 2, and that's going to give you the angle measure. And so that's going to give you 17 degrees. So inside you add the by 2, on it's just half the intercepted arc, and outside you subtract the 2 arcs. You always want a positive number with that one, so if you subtract the other way, just put it down in the positive number. Okay, that's 10-6. 10-7, we started to talk about circles and equations of circles. So if we write the equation of the circle, centered at 4, -6, so just for a reminder, I'm gonna write it up here at the top. It's x minus h squared plus y minus k squared equal to r squared. That's the equation for a circle. The first thing I'm gonna do is with the center, I'm gonna write that out. So it looks like it's the opposite of each one of those numbers. You're gonna write x minus 4 squared. So it's a positive 4, you're gonna write minus 4. Then it's plus, and it's gonna read y plus 6 squared. Minus -6, so it's plus 6. Then equal to finish that off, I need to know what the radius is. So you can find the radius essentially by doing a distance. Sometimes you can find it by counting, so just kind of think about what you're doing there. But if this is the center and it passes through that point, the distance between those two is the radius. So distance formula is just diagram here. 4 to 7 is 3 units squared, plus -6 to -3 is also 3 units squared, equal to the radius squared. Okay, realize that it's going to give you the radius squared. So 3 squared plus 3 squared is going to give you 18. Equal to r squared. I can find square root of that, square root of 18, but I'm going to write in r squared. Realize that this right here says r squared. So I'm just going to write that in as 18 and not my answer. That one is multiple choice on the final. I'll just say that. So when you're like, how do I write it? What do I do? Or whatever, it's multiple choice. Okay. State the center and the radius. This is just to make sure you understand that idea. The center of this one would be 2, -3. Have to flip the signs. And then the radius in this case would be 2. Okay, the points of intersection. We're going to do one here on 10-7 and one on 10-8 just to make sure we kind of remember this idea. If you don't have them both equal to each other, you're going to substitute. So if you're given, essentially, if you're given a circle and a line, you're going to substitute. You're going to take x plus 1 and you're going to substitute it in the y in the other problem. So here we have x squared plus the quantity of x plus 1 squared equal to 25. All I did was substitute that in. Right? And you have to multiply out x plus 1 squared, which remember is not just as simple as distributing a square. It's x plus 1 times x plus 1. So if you multiply that out, you end up with x squared plus 1x plus 1x, which is a positive 2x, and then plus 1. And then I'm just going to bring everything else with it. In order to solve, when you get into a quadratic like this, x squared plus x squared is 2x squared plus 2x. And I'm going to subtract my 25 over because I need it equal to 0. So it's minus 24 equal to 0. For our purposes, if you're having to factor, you're going to only have to factor with the 1 in front, which you can do in this case because you can divide all of this by 2. So you have x squared plus x minus 12 equal to 0. And you have to factor to find your answers here. So this is an x plus 4 times an x minus 3 as factors. And then your solutions are what makes that equal to 0. Well, an x value of -4 would make that first parenthesis 0, and an x value of 3 would make that second parenthesis 0. We're good. Okay. And then you solve for y. So the x value is -4. I'm going to take this y is equal to x plus 1 and solve. So it would be y is equal to -4 plus 1, which is a y value of -3, which gives me an answer of -4, -3 in parentheses. There's one of my answers. I'm gonna do a good job. That's my answer. X value of 3, you do the same thing. So y is equal to x plus 1. 3 plus 1 is 4. And so my other answer is 3, 4 in parentheses. Again, in the interest of time, because I wrote this, we're gonna skip this. I know you guys are so sad about that, but it's not. So. Intersection though, if you have this one, if you have them both equal to y, you just set them equal to each other. So if two things equal the same thing, they equal each other. The 3x squared is equal to 6x plus 24. And then from there, you're really doing the same thing as you did before. You're factoring in order to solve. So you have to get it equal to 0 and solve. I'm gonna, just for the interest of time, these let's do that. That we're doing the same thing we just did. I'm gonna give you answers, and then if you have questions, feel free to come to me. So 448 is one of the answers, and then -212 is the other point. Okay, so you would go through and do the same steps of factoring to get there. But again, the difference there is if they're both equal to y, then they sit equal to each other instead of substituting. Okay, so that led us to section 11, which was, or chapter 11, which I think all of us liked. It was when we got into areas and stuff like that. And we did pretty well. So trapezoid, your area formula, again, you don't have to have them memorized because you're writing them down right now. If you don't write them down, you have to have them memorized. But is 1/2 times the height times the base 1 plus base 2. So that's my trapezoid area. Right? In this case, my trapezoid is on its side. You have to treat the 11 as a base, and you have to treat this other side as a base. So this other side has an 11 up to that point. You've got the rectangle down there. And you could do this as just a triangle plus a rectangle if you wanted to. To find that third side, you would do the back theorem here. I'm just going to give us an answer. So it's a square root of 117. So you would do Pythagorean theorem to find that. And you can give it as a decimal. I just wrote it down as that. So I'm writing down there. So to fill in the formula here, it would be 1/2 times the height is the distance between the two bases. Not how tall a figure is necessarily, it's the distance between the two bases. In this case, it's the 18. Times base 1 is 11 plus base 2 is 11 plus that square root of 117. Right, and you can go through and do that. One reminder, do not make intermediate rounding errors, which means if you take the square root of 117 and round it to 1 decimal, you likely will have the wrong answer in the end rounded to 1 decimal. It'll be slightly off. So use the whole number of 117 until you get to the answer, don't round. Okay, so this is a reminder there. Parallelogram area, when you're looking at this, your area formula is base times height. We talked about how it was kind of like a rectangle. You have to use your 60-degree angle here. So if I throw my 38 across there, since those are congruent to each other, I actually just realized this is also a rhombus, but we're going to use parallelogram formula here. So if this is 38, that's the long side. This bottom little piece right here, then would be half of that, which would be 19. And then the height of this parallelogram is the long side there is 19√3. So to solve this one, you would be doing your base of 38 times your height of 19√3. And again, you give it as a decimal, so you would get 1,250.5. Well, I guess not. The other thing that you're going to see, and you'll see this on the final, is what if I give you the area and ask you to solve for something else? So this one is a rhombus. The rhombus formula is area equals 1/2 times diagonal 1 times diagonal 2. And so in this one, I know the area to be 841 equal to 1/2 a diagonal. Now it says twice as long as the other diagonal. So one of the diagonals is x, the other diagonal is 2x, twice as long. Okay, so one diagonal is x, the other diagonal is 2x. That's how we set that up. And then you would have to solve here. Now I did this. I said 1/2 times 2 is 1, so those go away. So I have 841 equal to x squared. That's what x times x is. You took the square root. And that's why I can find my answer there. Your x value in this case comes out to 29. And it does say how long are the diagonals. So once we'll put them. So the x one is 29, the other one was 2x. So double that, and that would be 58. So you have two answers there, 28, 29, and 58. I'm gonna do a little bit more. Okay, area of a regular polygon. It's up to you. It is 1/2 times apostrophe times perimeter if you want to use that. Most of the time, I just did the area of the triangle times the number of sides, so times n-ish, and so that's what I'm going to do here. So if this apostrophe is 32, then I'm trying to figure out that triangle that's in there. To find the angle, you take 360 divided by the number of sides, which in this case would be 60, divided by 2, and that's going to give me a 30-degree angle. Okay, so if you have a different number of sides, you divide by different things, you got to find that angle. Again, I did 360 divided by the number of sides, and then divided that by 2 to find that. Once I have that angle and I have this long piece to be 32, then I know that that short piece, that's what I need to know, is that divided by root 3. So 32 divided by root 3. For the purpose of this one, don't feel like you need to rationalize. Okay, you can even use a decimal in that case if you want to. So you have that little piece. That's all I need here because I need to know this whole length here. So that times 2, again, I can write it as 64 over root 3 if I multiply by 2, or I can have a decimal in my calculator right now. Right? And then to solve, the area of the triangle would be 1/2 times the base of the triangle, that's that 64 over root 3, times the height of the triangle, that's that 32, that's my triangle. And then I do all of that times the number of triangles, which in this case would have been 6. And then if you solve that, you would get 547.2. Okay, last one for today. Area of the shaded region, you just need to figure out in this one that this is a kite minus a triangle. Your kite formula is 1/2 times diagonal 1 times diagonal 2. Your triangle formula is 1/2 times base times height. If it goes down. So your kite, your 1/2, your diagonal 1 is 22 units long, and your diagonal 2 is 26 with the 13s together. Minus your triangle 1/2 times the base of that triangle is going to be that 26 across at the top there. Times the height of that triangle, since we have another 30, 60, 90, that 13 is the long side. This is going to be 13 divided by root 3. So that's your height. So 13 over root 3 is what I would do there. I've got all in my calculator, let it figure it out for me. I get 188.4. Yeah, we're stopping there. Okay, so we'll finish 11 and 12 tomorrow. Again, I will post this recording so you guys have that. I will also post these answers, so I'll copy these down and post those in just a little bit, so you'll have all of that stuff.